How's it going, YouTube? In this video, we're going to do number 543, diameter of a binary tree. So given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of the path between the two nodes is represented by the number of edges between them. So this is going to be a depth first search problem. So basically what we're going to do in this video is we're going to code up the solution first, and then we're going to explain exactly what's going on, right? So remember, when we're doing depth first search, you have a general format that we want to do. We want to have edge case, we want to have the condition, then we have to have the also the kind of tree path, or the return value in this case. So let's code it up. So what we're going to do first is we're going to define a global variable, which we're going to return, which is self.diameter. I think that's how you spell it. Alright, then we're going to define our function. So define, I'm just going to call it DFS. Then we're going to do current node. So if current node is none, return 0. And now we're going to have our condition, but before we get to that, what we want is LH is equal to DFS current node dot left. Then we have RH is DFS current node dot right. So here we're just recursively calling the function again because we want to traverse through the entire tree here, right? So the next thing we want to do is we want to have our condition, right? So if LH not LG is not none and RH is not none, return 0. Then what we want to do is we want to find our maximum, or if LH is not none and RH is not none, what we're going to do is we're first going to define what our current diameter is, which is going to be LH plus RH. And then what we're going to do is we're going to take the maximum. So we're going to go self.current diameter is equal to self.diameter. We're going to take the max of the diameter itself, and we're going to have the current diameter, right? And lastly, we're going to have a return value here. So we're going to return the max of LH, RH plus 1. Now the last task we need to do is we just simply have to define, or call it rather. So we're going to go DFS root, and we're going to return the diameter. And as you can see, it should pass all the cases. If I can put the self. As you can see here, it actually passed. So it was successful. This is an O of n solution. Now the question is, how exactly does this formula work? So let's go back to our equation here, and let's write down each of the key values here, right? So we have our current, and this is basically going to be what's happening in the tree. And then we're going to write the max, LH, RH, right? So as you start to go through the function, we need to know that as we're going here, we're calling this LH here, and then we have RH here, right? And if we go through the equation again, we're going to realize that LH2 is equal to LH4, right? And LH and RH2 is equal to L, or RH2 is equal to H5, right? I'm just going to put, or let's erase the over here. So we're more concerned about what's happening at node 4 here, and we're more concerned about what's happening in node 5 here, right? It would make a lot more sense for this this question if they actually use letters instead of numbers, because the numbers can confuse you. And basically what's happening here, it's almost like it's two separate things that are happening right now. One part of our algorithm is calculating what diameter that we have, and one of them is traversing the tree from bottom to the top, right? So if we go here, we can see here that we have LH4, and take a look at our code. This is actually really interesting. Since the next step here is, current node is none, LH4 is going to be 0, and so is RH4. Right? So now that we have RH4, we can start to develop the values in our equation. You can see here these are all leaves, so we can all assume that this one is also going to be 0. Or that's RH5 is 0. Then we have RH3 is 0. And LH3 is 0, right? So what's happening here? Now if we take that max of the LH and the RH at 4, for example, we have 0, 0, and this is going to be plus 1, as you see in this question here. So 0 plus 1 is going to be 1, right? So what happens here is we're going to return. So this is going to be 1, and then now LH2 is equal to 1, right? I'm going to do the same thing for there, but we already know the answer here, so it's going to be 1, right? So now let's take the diameter here. Current is equal to 0 plus 0, so our current is obviously going to be 0. We set the default value of 0 to our diameter, so our current max is going to be 0, right? So now let's move to the top here and start calculating both values, right? So we have here LH and RH, right? So LH is going to be 1 and 1. And the max of 1 and 1 is obviously going to be 1, so that's going to be 2. So we're going to go 2 over here. That means that LH1 equals LH2 is equal to 2, right? And we got RH1 equals H3 equals whatever. So basically we're calculating the H3s up here so that we can use in this equation, right? Now we're going to do the same thing for the diameter here, right? So if we go here and we're going to do brown, so current is going to be 1 plus 1 is 2, and our current diameter is obviously 0 at this point, so our new max is going to be 2, right? So now we store that as our max so far. Alright, so we're going to move on. We're going to go to 3 now. So obviously 0 plus 0 plus 1 is going to be 1, right? So we're going to add that. Oops. Right, so now let's calculate the current here. 0 plus 0, this is still going to be 2. And then over here, we got LH1, which is 2 plus 1 is 3. So 2 plus 1 is going to be 3. Our diameter is 2, and therefore our new maximum, and just so happens that that's what it's going to return, is going to be 3, right? So that's the premise of how this algorithm works. Is you take two separate functions, the max of the left hand side and the right hand side, and use it to traverse up the table. And then you have diameter, which is going to be a separate calculation. So basically what's happening here is you have the tree that's being calculated, so you know exactly what left hand values and right hand values that you have. And then from there, you use those values to calculate the diameter, right? So that's essentially how this is going to work, and this is how it runs. So basically, this is an algorithm that runs in O of n time. Very efficient. So I hope that explanation was clear. If you guys enjoyed the video, feel free to give me a like and a subscribe, and I'll see you next time.